Good day, folks. Today we are going to take a look at applying the quadratic functions that we've been learning about. Our objective for today, our know, is to apply our knowledge of quadratic functions. And our do, you'll be able to do a problem much like one that is seen in the do. Now, for our wicker know and do, our wicker know is the meaning of the word quadratic function. Now, let's review for a second quadratic equation. A quadratic equation, remember, is an equation. For example, let's say that you had, say 0 is equal to, let's say just x squared plus, and it could be anything. Just really doesn't matter. The key is that x squared, okay? So to make it a function, instead of us putting a 0 right here, we would simply have f of x. So if I erase that and I put f of x equal, that makes it a quadratic function. All right, so let me very quickly just draw this here. So that makes it a quadratic function. All right, so then our essential question today is, what is a quadratic function? All right, I want you to pause this video for a moment, and I want you to make sure you have two things. One is a Cornell note guide. Make sure it's in front of you because you're going to be filling it out as we go. Second thing I want you to have is your Inspire graphing calculator. So go ahead, pause the video, and go get those two items. All right, let's take a look at the first problem. It says, at a fireworks celebration, a bottle rocket is launched upward from the ground with an initial velocity of 160 feet per second. Initial velocity, 160 feet per second. I'm going to go ahead and underline this because that is an important part here. Initial velocity is 160 feet per second. All right, now spectators watch and wonder how high the bottle rocket will go before it reaches to descend toward the ground. A formula is given. Now this is one much like the one that I gave earlier in the notes in section 3.2. where the gravitational constant is going to be negative 32 feet per second squared, okay? And v, your initial velocity, okay? And s is your initial height, okay? So those are the three pieces here. So we have our a value, which is your initial, which is 32 feet per second squared. V is your initial velocity, and s is your initial height. Now, the time t is measured in seconds here. And of course, your height is measured in feet. Okay, so those are the important parts about this problem. Okay, so what we're going to do here is I'm going to take this information here and we're going to plug it into this formula right here. Okay, so first of all, if I take, remember what my v was. My v was 160 because my initial velocity of my rocket is 160 feet per second squared. In other words, my rocket can blast up 160 feet for each second it's in flight. Okay, secondly is my initial speed. Well, if it is sitting on the ground, what is my speed? Yeah, it's going to be 0. Okay, now a, that is my constant. Okay, so it is going to be 32 feet per second squared. All right, so I'm going to plug my a value right here in for, so it's going to be 0.5 times 0.32 t squared. And when I simplify that, notice it comes out negative 16 feet per second squared. Now, some of you are probably thinking, oh my goodness, we've seen that. Yes, we did. We saw that in our yesterday's notes, negative 16 t squared. All right, then we plug in our initial velocity. So the initial velocity is 160 feet per second, because that's how many feet per second it can go. All right, and then we have our initial height. Well, if the thing is sitting on the ground, how high off the ground is it? That's a trick question. Or is it? Well, if you said 0, you are correct. So my equation is going to look like this. Now, I want you to take that equation, and I want you to plug that equation in into your calculator. Okay, so go ahead and pause this a second and enter it into your calculator. Now, when you enter it into your calculator, remember what you did. You click the on button, and then you went ahead and selected number 1. Okay, and you want to do a new graph. So click New Graph, and it comes up. And you have this f of x equals, okay, so that's where you're going to enter the function. So we're going to type in here negative. Make sure you hit the negative button right here, not the minus button, but the negative. And you're going to have negative 16. Now, you don't put a t in, put an x in, because that's how the variable works in for the graphing calculator. And then hit the square button. And then you're going to hit the regular plus button here. And then you're going to type in your 160 x. Okay, so enter that function. Now, once you've done that, you're going to hit the enter button, and it's going to graph it. Now, when you do that, you're not going to see very much. Okay, but that's all right, because remember that rocket blasts up to at 160 feet per second, so you may not see anything. So what I'm going to do here is I'm going to, grab this screen here, and I'm going to zoom in a little bit. So notice I'm grabbing the axes just like this, and I'm just kind of going in just like this. And what that's going to do is it's going to, it's going to pull it in, and it's going to show me. I can also grab the screen much like this to kind of see it, okay? Now, I need to kind of spread this out a little bit. So here, let me get this thing out of the way. So if I spread this out, okay. All right, now I want you to pause it, and I want you to just play with the screen. If you do what I did right there and don't get very far, here's one thing more you can do. You can go to Menu, and you can go to Window right here, and go to Window Settings. And then play with your window settings, and I want you to play with this. Now, you want your x min to be right about, say, -1, okay? And you want your x max here, well, how long is it going to be in the air? Well, I would guess it's probably going to be in the air about 10 seconds, okay? Then what about your y? Well, we don't need to go into the ground, -34 feet. So I'd probably put that at about, I'm going to put it at -1, because I like to see just a little bit below the axis. And then the y max, we're going to put, and I don't know how high it's going to go, but I know it goes 160 feet per second. So let's say it's in the air maybe 5 seconds or so. So I'm going to punch in maybe, I don't know, 500 feet. Let's put that in there. And then go ahead and click enter. Oh, look at that graph. It came out nice and pretty right there. Okay, so that's what your graph is. Okay. All right, so go ahead, pause it, and go ahead and make your screen look like my screen. Okay, now that your screen looks like my screen, we're going to split this screen and look at a table. Here's how you do that. You're going to hit the menu button again right here. Hit menu, and notice right here it says table. So you want number 7, and then over here, so menu 7.1 gives you a split screen. So click split screen, and then you see this table right here, and you can kind of use your up and down arrows to look at this here. All right, now I want to go from about 1 here. So and notice this is where the time is 0, and notice that the bottle rocket's on the ground. Okay, notice what happens after 1 second. How high it is, 144, and so on and so forth. At 2 seconds, at 256. And you can continue to look at this and just keep going down. Ooh, it looks like it hits at maximum point at about 5 seconds, reaching 400 feet. And then it goes right on back down. So in 10 seconds, it hits the ground again. So what does that mean? Well, that means that it's in the flight for 10 seconds. And it hits a maximum flight at 400 feet after about 5 seconds. Now go ahead and pause the video, and I want you to record this information, both the graph and the chart, on your Cornell note sheet. Okay, so now that you've done that, this is what your table should look like. So if we get rid of this, it should look something like that. And of course, let me flip over to this. This is what my graph should pretty much look like. Now make sure you scale along here and scale along the x-axis as well. And notice how I wrote the function kind of right in here. All right, so now the next thing, let's look at the domain here. What happens? Now remember, your domain is along the x. What is my x values along the domain here? Well, if we took a look here at our chart, notice I went from my domain of 0 seconds up to when it hit the ground again at my domain of 10 seconds. So that means my domain is going to be between 0 and 10. Now we can put that in set builder notation. So it looks like this. All right, now what about the range? Well, let's go ahead over here and look at our graph again. So if I look at my range, now let me look at my table here. Notice my range, which is how high it's off the ground. So this time we're looking at our y-axis right there. It is at 0 feet, and it goes up and up and up and up and up until it reaches about how far? 400 feet, and then it stops. Or it doesn't stop, but it stops going up, and it curves and comes back down, and then it hits the ground back at 0 after 10 seconds. So that means our range value is going to go from 0 up to 400 feet. Okay, so it's going to look like this if we put it in interval or in set builder notation. Okay, so that's what it's going to look like. All right, now let's go ahead and take a look at what this is at our next question. Okay, so if you're not caught up with me, pause it. If you are caught up with me, let's move on. Okay, moving on, it says, how high is the bottle rocket 3 seconds after launching? And will it ever be that height again? Well, let's take a look at our graph. If you look at our graph, you're going to notice that it goes up and then it goes down. That's what that's the path of your bottle rocket. Notice if I move this line here, let me grab this line, but if I move this line along, notice, after so many seconds, it's going to be a certain height. But then as the bottle rocket goes up, remember the line of symmetry runs down here. It's going to have a point over here that same distance away from the line of symmetry. So yes, as the bottle rocket goes up, it's going to hit that same height again someplace over here on the other side of the axis of symmetry. All right, so when will that be? Well, if we take a look at our graph here real quickly, so let's look at our graph, we can see, you see your axis of symmetry is going to be, remember, it's going to be x equals h, so x equals 5. And so you're going to see on both sides here, ooh, look at that. At 3 seconds, it's at 336 feet. And then again at 7 seconds, it's at 336 feet. All right, so let's go ahead and put that down here. So it says, how far will it be at 3 seconds? Well, it's going to be 336 feet. And then when else will it be, or what other time will it be at that 336? Well, after 7 seconds. All right, let's go to the next blank here. It says, for the audience's safety, the bottle rocket, as it descends, should be set to explode at 250 feet above the ground. In other words, we don't want it exploding when it just barely leaves your hand. Okay, the operator has a choice of fuses to put into the rocket. Fuse A will detonate the rocket between 3 and 5 seconds. B between 4 and 6 seconds. And C between 6 and 8 seconds. All right, when is the best time to do this? Okay, so think with me here. We blast off that rocket, and it's gonna blast off either, again, 3 to 5, 4 to 6, 6 to 8. All right, so let's think now. Here's our time. There's to go to 10 seconds here, and how high is it going to be? Well, now let's go back to our graph, and let's just look. Okay, if it goes off, say at the minimum 3 seconds, it's going to be this height. If it blasts at a minimum of 4 seconds, it's going to be here. Okay, and let's go back. Okay, now, so 4 to 6 seconds, the other 6 to 8. All right, the choice C would be it blasted here. Okay, so do we want it, okay, choice A, to blast at around 3 seconds, around 4 seconds, or around 6 seconds? Well, look at your graph. 3 seconds, it's here. 4 seconds, it's almost at its max. And 6 seconds, it's on its way down. So when do you think you want it to blast? Well, my thought, we want it to blast at the highest point. So I would say choice what? B, somewhere between 4 and 6 seconds. You are correct. You want it to explode somewhere between 384 feet and 400 feet above the ground. All right, so that is my thought as well. All right, so now let's go on to the next question. Now, the next question says, suppose the bottle rocket is launched from the top of a 200-foot tall building. Now, if that's the case, how will that change my initial height? Well, instead of it being 0, it's now going to be how high? If you said 200, I agree with you. So how's that going to change things when you plug in your equation? Well, what do you plug in for S? Instead of plugging in a 0, you're going to plug in a 200. That's right. So now how's that going to affect your equation? Well, you simplify it, so it's going to simply just look like this. Okay, now I want you to take your calculator. So what we're going to do, let's go back to your calculator. Now, I want you to hit Control G. So when you hit Control G, you know what? Before we're doing that, let's get rid of this. Let's get rid of this chart. Okay, so go ahead and hit Menu and go to Table. So Menu 2 and then remove Table. All right, now hit Control G. And notice it pops up an F2 here. Now, this time, what I want you to do is you're going to enter the same function, but instead of just stopping at 160x, you're going to plug in that plus 200. So it's going to be negative 16 x to the second power plus 160 times x, and then it's going to be plus 200 because that's how high the building is that we're launching the rocket from. Now, in doing that, we also have to adjust our window. Remember how we adjusted the window? Well, let's see. We went to Menu. You went to Window, which is number 4, Settings. And because it's going to be in the rocket in the air longer, I'm going to run this out. So how far? Well, let's just try some things. Try 15. See what that would happen. And how high? Well, let's just play with it. We don't know for sure. Let's just, shoot it up a little bit further. Let's go up maybe another 100 feet and see what that'll do. So, and look at that. There we go. I have the whole graph. It's going up. Looks like it hits right about that location, comes down. Good job. Okay, so we have it, so we can see that. All right, so now that we have this, let's go back to our sheet, and it should show, it looking just something like this. Okay, so you're going to go ahead and put that in your box, and then go ahead and split the screen again. Remember how we split the screen? Menu, then you went 7, 1, and now you can see where it's going to be. Now notice function 1 was in this column, function 2 is in this column. Okay, so we can go and we can see just where everything, is going to be. All right, so move it down, move it up. You can see what's going to happen. Ooh, you can see the new height. The new height is at 5 seconds this time. Instead of, oh my goodness. My new height was at 5 seconds before, and it's still at 5 seconds. So it didn't change the axis of symmetry, did it? It just got up higher. What changed is what? Look over here. Ooh, my initial height at 0 changed. Okay, which means it went up another 200 feet. See the difference here? All right. And then look down here. Okay, looks like it was in the air. What? Ooh, another how many seconds? Well, it looks like it was in the air a little over another 11 seconds, just barely over more 11 seconds here that the rocket was in the air. All right, so let's go back to our sheet and let's answer some questions here. All right, so, oh, by the way, go ahead and fill out your chart. Get that all like it needs to be. All right, go ahead and pause it and finish filling this out. All right, guys, now let's go ahead and answer some questions about this. On the last box there, it shows some compare and contrast there. All right, so as we're comparing and contrasting, now compare means how are they the same? Contrast means what? How they are different. Now, as we talked about these, we talked about how they're the same, how they're different. Okay, go ahead and pause, and I want you to go back to here, think about some of the things that we said here, and I want you to write a statement for how they are the same and how they are different. Okay, go ahead and pause it. All right, guys, so now that you've done that, let's go ahead and this is what I put. So you should probably have written something similar to me, probably some different things too. That's good. All right, now the last little piece. Suppose you are the fireworks operator and you want to launch a bottle rocket from the ground and have it stay in the air 3 seconds longer than in the original scenario. How can you accomplish this? Now think of, I'm sure most of you have launched bottle rockets, or at least you've seen it before. What could be some things that you could do to get it to be in the air longer? Okay, go ahead and pause it and write some things down. All right, guys, you've done that now. Now, here's what I'm going to guess you probably said. I bet you said, knowing that you probably, like myself, have done this, my guess is you held your bottle rocket in your hand. And instead of launching it from like a bottle, you threw it, which is more dangerous. So I would not recommend doing this. But my guess is if you could somehow increase the velocity of it, and ways of increasing the velocity would be maybe to launch it so its initial velocity was at a different speed rather than the initial velocity being 0. All right, and that's what I said here, on this, And by the way, if you took this here, let's go back to our calculator here, and I want you to hit Control G. Well, first of all, we need to get rid, click on this screen right over here. Hit Control G, and I want you to arrow up, and I want you to go back to equation number 1, and I want you to arrow over to that initial speed that we said 160. And I want you to change that a little bit and just see what happens. For example, if we were to type in 200 and then hit enter, what happens to the, ooh, look at that. I'm going to grab my screen and pull it down a little bit. It goes up higher. Okay, now let's do that again. Hit Control G again, go up, and let's go over and let's play with it and see what happens if I go up even a little bit higher. Like, let's go 220. Hit enter again. Ooh, look at that. It even goes higher. It even goes higher. So what does that tell you? That tells you as you increase the initial speed, the rocket is going to go higher in the air. Okay, so you can play. And this is what I said here. By experimenting with different initial velocities and graphs, you can see that the initial velocity needs to increase to about 200 feet per second. All right. Well, guys, that wraps up this activity. Now, we have a little project that I want you to work on. So I want you to go get the worksheet that looks like this one right here. And I want you to use your Cornell note sheet and walk through this activity. And whatever you don't finish in class is going to be homework. All right, folks, well, that's going to give it a wrap. Have a good day, and, of course, have fun. One thing I want to mention, if you remember, if you need to, you can't take your graphing calculator home. So what do? If you're at home and you need to graph some of these things, yes, you can use your AlGeo graphing calculator or your Good Grapher, or you can get on the website and use that Flash plug-in little app there from my website to graph things on your computer. Okay, folks, well, that was fun today, so go play and have some more fun.